This is a report about the restoration and partly rebuilding of a 216-year-old iron tower clock, a fully mechanical wheel clock. It was originally located in the municipality of Bezau in the Bregenz Forest. The church was completely rebuilt and enlarged. The clock mechanism was replaced. I bought the clock in 1985 in a rusted, poor condition. Some parts were missing. In 1904, the tower clock was already restored once before, and the escapement was rebuilt, respectively modernized. I rebuilt it to the original conditions and replaced the Graham escapement from 1904 with the classical returning escapement. Before dismantling, the photographic recording and labeling was very important. In addition, museum visits, interviews and the studies of relevant literature helped me to understand the complicated mechanics. An iron tower clock can be completely dismantled in all parts. The frame is assembled with plugs and wedges, so the heavy parts could be carried up into the tower where they were reassembled. This iron wheel clock consists of 3 individual units, which are, however, mechanically related. To the left, the unit that takes care of the quarter-hour strike with a stone weight of 26 kilos. In the middle, the actual clockwork with a stone weight of 30 kilos, with the lever escapement and the pendulum. On the right is the hour striking mechanism with a stone weight of 26 kilos. The most important element in this movement is the escapement. It regulates the speed and prevents the winding weight from sliding down out of control. Using angle calculations and a wooden model, I had to find the angles of the new construction of the escape wheel bit by bit. In order to have as little friction loss as possible, the escape wheel is often made of brass and the armature is made of hardened tool steel. This toothed disc on the central clockwork originally transmits the rotation with a spur gear to the dial hands in the tower. At the same time, the movement can be synchronized with the striking mechanisms. From there, the lifting impulse also goes to the quarter-hour hammer on the left. The central movement also transmits an impulse mechanically to the quarter-hour strike by means of a rod. The rod lifts the latch at the final wheel and starts the striking mechanism. Originally, there was a rope or wire pull to the hammer on the bells in the tower. The length of the pendulum and the weight of the pendulum determine the speed of the clock. The pendulum itself was originally 1.5 meters longer and the weight of the pendulum heavier. This small toggle lever transmits the starting impulse to the hour hammer on the far right via a long lever. This again lifts the latch at the final wheel of the hour strike mechanism. In both striking mechanisms, a wind wing prevents uncontrolled fast running. At the sudden end of the rotation, the wind vane can run on and slow down with a ratchet. There is enough rope on the 3 reels for the weights originally in the high church tower. I didn't count the hours on this restoration. I learned a lot in the process, had a lot of fun and was able to expand my technical knowledge.